So hello everyone, in today's session we'll be discussing about the different addressing modes available in ARM7. So very first thing that you should know is what exactly do you mean by addressing mode. Okay, if you are discussing about load store instructions, then addressing mode tells CPU how to compute effective address used by LDR STR. So what do you mean by effective address? So in case of LDR STR instruction, your whole purpose is to access a particular memory location, and your purpose here may either be to read some data from memory location or to write some data into the memory location, correct? But that is not important here. Our focus is finding this exact location. So this particular memory address, okay, is effective address. Okay, it's the actual memory location or memory address from where you want to read or you want to write some data. Okay, fine. So this particular effective address is calculated by the CPU with the help of addressing mode. Next, what we have is data processing instructions. In case of data processing instruction, how exactly or why exactly addressing mode is required? Let's take any instruction move arg1, hash 3 move r2, r3 or something like that. So in this particular case, what second operand or operand 2 should be taken is determined by which exact addressing mode we are considering. Okay, so those are few things you need to know about the addressing modes. So these are the different ways in which data processing instructions accept operand 2. Okay, that is immediate, register and register with shift or rotate. The addressing mode in which immediate operand is used or accepted is called as immediate addressing mode. This is called as register direct addressing mode, and this one, that is register with shift or rotate, is called as scaled register addressing mode. So this is the example for the very first type of addressing mode, that is immediate addressing mode. You see an instruction here where you have addition operation to be performed between R1 and this immediate constant value. Okay, and the result is supposed to be stored in R0. Why does it belong to immediate category? Because the operand 2 here, okay, is nothing but 8-bit value. Okay, but is it just 8-bit? No, you can choose any value here. Okay, you can write something like, even 0x4. Even this big value is allowed. Okay, but upon one condition, that this can be converted into an 8-bit value, for example, okay, such that when it is rotated by even number of times, for this particular case, if you rotate 8 times, what will happen is you will obtain the larger 32-bit value. Okay, any number or any immediate constant that you take here will always follow a rule, or you should be able to convert it into an 8-bit. Now here it is hexadecimal 40. If it is rotated 8 times, you will get this particular value. And in this particular case, if you choose a constant which doesn't satisfy this particular condition, then that particular instruction won't be executed. Next, we have register addressing mode. As you can expect, the second operand should be a register. That's all. In the next case, there is minor modification. You are considering a register itself, but it is shifted or rotated by some particular value. Now here LSR, this is logical shift left, logical shift right, arithmetic shift right, rotate right extended, or rotate right. All this are possible for this particular register and can be incorporated in this particular data processing instructions. So this comes in the third category, that is register with shift or rotate. So what happens here is R2 content is shifted to left by 2-bit positions, and that answer is added with R1 and that result is stored in R0. That is, if R2, let's assume, is some value 2, okay, 2, when you perform logical shift left by 2 times, you know it will be 2 into 4, which is 8, okay. So this value 8 will be added with the content of R1. Let's assume R1 is some value 3, so result 11, but 11 in hexadecimal is nothing but B. So the value B will be the result stored in R0. Now let us discuss the different addressing modes supported by LDR STR instructions. If you notice just the names here, you can see 3 different index methods here, that is pre-index, pre-index write back and post-indexed. What do you mean by this? We'll learn that in the upcoming slide. And next to that, we can see same things repeated, that is immediate offset, register offset, scaled register offsets. Immediate, what we noticed last time was some constant we had considered, okay. For register, what we had considered for data processing instruction is that the second operand was always a register, and we considered something called register with shift or rotate. Same thing happens here, okay. Offset are values to be added to base register content. What exactly it is, we'll discuss that in detail in upcoming slides.